All right, we are covering caffeine in this lecture or series of lectures. I haven't decided how this will get broken down. I'm trying to decrease the length of these to make them more digestible, sort of pun intended. But so let's get started. If there's anything, I'll cover some of the. I'm going to adjust some of the assignment points this week. So look for that and I'll get responses. If you have questions about some of the questions in the quiz, I will get back to those as well. But as we get started here, for caffeine, this is, I think most know that this is the most commonly consumed ergogenic aid. So people don't consume it for necessarily sports performance, but for some of the health and or stimulating attributes. So before we kind of get started, I'm trying to change my pedagogy a little bit. We'll see if it helps, if it's any better. I'm trying to prove too. I'm trying to learn, and so just either pause this. I'll give a couple seconds to kind of think about the issues that you see, and this make it relative to athletes and sports performance. You could go tactical and military or just human performance if you would like, and that's fine, but just kind of reflect on what you know, what you either have heard, have read, either in science or in other media, papers, etc. And we'll see if we can address those and then maybe provide something new. All right, so what is caffeine? Caffeine is a relatively small molecule, 2 rings, and so I get my mouse to work here. One of the key issues is the bitterness from a flavor perspective. It is a methyl xanthine. This was brought up in lipid metabolism. It'll come up again today. And so hopefully it'll be a review of that content. But if it didn't make sense then, hopefully it'll make sense here too. Or new sense, whatever. And two key things from a sensory type perspective. One is its bitterness. And so I don't know, some of you may have had Vivarin or No-Dose, a generic version of those. I think Walgreens may make a generic version of Vivarin. One of the companies like Walgreens, CVS, I can't remember which, has a generic version, but it's a tablet. It's not most caffeine that you might get through GNC, Amazon, wherever supplement you may get supplements from. It's typically in a capsule, a gel capsule, but the tablets, and most tablets over-the-counter caffeine-only products are either typically 100 or 200 milligrams, and we'll talk about some of the other aspects near the end here, but at the end of this series. But the bitterness is, if you've had those tablets, it's pretty intense. So that's something to consider when using a lot of caffeine products. And so some of them, especially the shots now, like 5-hour energy drink and things like products like that, given the concentrated dose, it does tend to be a little bit more bitter, and the content of the caffeine. So that's something that's kind of off-putting to some people, which is understandable. Bitter is not necessarily a preferred flavor, or I guess taste sense. There's anhydrous powder, and so it doesn't really clump that much as like sucrose or fructose, those types of things. But for example, there are some pre-workouts that have glucose or fructose, a carbohydrate source, in them. I think one is Gatorade. I think it's Gatorade that makes Fast Twitch, I think, and they make a powdered version. And so there's some carbohydrate in that. So there's a potential for clumping, but anyway. The other aspect is it's found in a lot of plants, and so it's a naturally occurring compound, and that's why it's historically been used primarily as a coffee or tea. And I use those terms loosely, like loose tea, loose leaf, unintended. And so it's been around for a while, and there's different varieties, different concentrations, and since they are in plants, historically there's been just different amounts of caffeine in those products. And so like tea, for example, green tea or green and black tea, because it's basically the roasting of the leaves from the tea plant, can affect or does affect the caffeine content, so, and the variety. So there's just a lot of options there, and same with coffee, I guess, in working with that. For the effects, also, there's an enzyme within our liver. Well, there are some genetic issues with this enzyme. This enzyme, which is limited with some people. It's so they're more caffeine sensitive, and so those people who have this genetic issue, I think they know that. Similar to those who have issues with metabolizing alcohol from a liver enzyme, kind of understand that too. And so anyway, but once caffeine comes in, it can be further broken down into paraxanthine, theobromine, and theophylline. With some of these, like theobromine, as I understand, it's the caffeine that's in cocoa, and then theophylline is typically what's found in teas. It's also a bronchodilator, and so I need to check. I don't know. I haven't checked since putting this together. There were some over-the-counter bronchodilators that were made with theophylline. I'm not sure if those are still on the market or not, but like Primatene Mist, I think, was one of those products. So for those that kind of remember that product, tasted terrible. I had exercise-induced asthma, so I tried a number of products. Anyway, so that's what happens in the liver to break it down and to metabolize it. And then another organ that's affected by it, several organs are affected by it, but for renal function, this is where one of the cautions comes, is the urine production and potentially enhancing dehydration, depending upon the amount of caffeine and other aspects of hydration status, fluid intake, etc. A potential likely benefit, and this may be also due to the amount and type and source of caffeine, but tends to elicit less renal stones and renal fibrosis or kidney stones. The issue I have with the diuretic aspect is there are other components. So what you'll often hear is caffeine leads to dehydration. Not necessarily said that directly, but sometimes it's somewhat that direct. And so for energy drinks and things like that, it's like or coffee, you'll get dehydrated, and I'm not disagreeing with that as a potential outcome. Whether it is an outcome or not is dependent upon other factors. And one, I mentioned the dose, environmental factors, how hot it is, training load, or how much exercise you're doing that day, or how much training the athlete is doing that day, the mental state of the individual, and then other foods that might be consumed along with that. And so, for example, the example I use for this to illustrate kind of how this may be perceived or may be exacerbated, that may be the best term, is espresso versus brewed coffee, drip coffee, in which you may be able to ingest the same amount of caffeine in the espresso and the drip coffee. However, the amount of fluid in espresso is very little, and if you have like 12 ounces of coffee to get the same amount of caffeine, there's more fluid and more water that's ingested with that caffeine. The simplest way to do it is, I guess, for an Americano, and you get 12 ounces or 1 ounce or 2 ounces of espresso, and then 10 or 11 ounces of water. If you just do the espresso, very concentrated, higher likelihood of dehydration than the Americano. So I'm not saying that drinking Americano will prevent dehydration. I'm just saying that there's some context that needs to be included in understanding the risks of dehydration. And as long as the athletes kind of understand that and are aware of that, I'm less concerned about the dehydration issue, unless it's really, really hot. And then there's other things it's a focus on hydration. Not that you shouldn't ingest caffeinated products, but to be as heightened as you probably should be in those types of situations as far as awareness for dehydration. Here's just some general info. This is an older study. One of the issues I like about it is they used decaf, so the gray here is decaf, and they also used habitual and non-habitual coffee consumers. So these are the non-habitual, the black bars, gray bars, and then the habitual are the clear bars, white bars, and the effects for sympathetic nerve activity. And so the central nervous system and this is just these, in essence, there's different people here. They've sequestered them out. These are all of them together. So caffeine and placebo are here, and what you see is increased blood pressure, in essence, increased contractility of the heart, and then with blood pressure, it's mainly systolic. Diastolic doesn't change much. Now again, you have to look at this from a science perspective, because some people may say, oh, my diastolic pressure goes up, and it may, and these people, it did, and it just doesn't go up as much as systolic does. Just because the contractility, I mean, if you look, these two, the systolic mirrors the burst and the sympathetic, or the central nervous system, and the contractility and the amount of activity. Interestingly, heart rate can decrease with caffeine because stroke volume, the issue is, are they exercising or not? In this case, they are not. And so the oxygen demand doesn't change within the cells much. So if your heart's pumping more blood and it's more forceful, stroke volume it's not measured here, but just based upon the math, it's gone up a bit, and so that's why heart rate will drop a bit. And then the amount of caffeine in the system is really high, so in a short amount of time, it spikes and then kind of levels off up to, in this case, 75 minutes, and that's an individual difference of dose, habitual intakes, etc. And just some interesting things, if you look on the slides, just the difference, how habitual intakes over time, the effect on systolic blood pressure is minimal. And so for those people who really consume on a regular basis, the effects that are seen here tend to disappear over time. I'm trying to think here of, and so you can see some of these responses, the decaf and the caffeinated and the non-habitual, same, yet the amount of caffeine in the blood, significantly different. And so this is how even decaf can have a response. Now, maybe it's psychological, not sure, but the issues with habitual intake and non-habitual intake is important when studying caffeine.